Also, we had initial idea of having hole punches on the drink because we didn't know that our bar is going to be open or not. And then Ken told us that the drinks are going to be open, so that saved us some of the other cylinders to add on to them. These are some of the pictures and the videos just while we are working. This
was one of
our initial ideas. We only were thinking of having one drink, but then Ken said we need to have 3 drinks. And also our platform was too high, so the drink would pass the other 2 drinks. That's why we had to cut the platform and have a lift cylinder which will lift the platform up and down to get the drinks over to the pouring place. And this is another video of it. The name of our design is the soda serving machine.
Soda serving machine.
It actually gets the desired drink that you want, and you can choose from any of the drinks from here and push a button and it will pick the drink and pour it into a glass for you. And our initial cost, our cost was supposed to be $200 as we are 5 people, but we went about $100 extra on it. We are like $300.
Ooh.
But it does the work, so it's worth spending money, right? And I wanted to describe the control panel as well. These are the 3 push buttons that we have, which will select each of the drinks, any of the drinks that you like, and drink 1, drink 2, drink 3. This is the MCR, the master control relay, which will give the power to the outputs. And this is the stop button, which will stop the machine at any part of the sequence if anything, any unharmful things that happen and stuff. And there's the E-stop, which will tell the power to the whole machine. Moving on to Marco.
Okay. There was a lot of freebies for us in this project, and luckily, because we wouldn't have been able to afford everything that we had to do. Some of the things were this. One of our main finds was this rodless cylinder here, which saved us a lot of machining because we were going to use a dual acting cylinder, and we would have to machine a rest for it. So this saved a lot of problems. And another big find was this gripper right here. We found that, so it saved us. We didn't have to actually come up and manufacture our own, and we just used a small cylinder to actuate it back and forth. We're using an Omari PLC, which is the main brains of our machine. And we're using a lift cylinder that we had to use because this box was, as Viren pointed out, was originally too high, so we had to compensate for that. Some of the things that we built were the gripper mounts. All these were machined in the machine shop. Here, that took a while to design and come up with the proper layout for that. As you can see, there's a few components to that. It took a while to machine that. That was probably one of the most machining we did on all this project. That's just a fully assembled. The next is the stand that we had to build for the drink dispenser. We used angle irons, and we welded 2 plates inside of it to give us support. And one support was the mount for the pouring rod, and then we mounted the DC motor on top of. Here, just a painted picture. We have the aluminum rod supports inside. Now this cup here, the pouring device, we actually, it was a pencil holder for a desk, and we used another cup as the yellow one inside there. We placed that inside to support the bottle. And then we have brackets on either side that we wired in, and we used screws to bolt everything together. The gears are press fit together. This is the rod, the pouring rod. It's 3 pieces. And we press the fit together with the gear so that we got a nice tight fit, so we could get the rotation we were looking for. This was the original motor we used, but it didn't end up working out too well. But it was the same concept to attach the adapter for the gear. It was we used the set screw to attach the motor, and then we press fit the gear to the plastic, and that worked really well. This is just the control panel, and the stand was made out of wood. I know it's not the best thing for wood and electricity, but we didn't have enough money to actually afford a real metal control panel. And that's the main machining. Okay.
Hello everybody, my name is Kushal, and I'm here to present the sequence of the machine, and I will actually run it and I will show you how it works. So basically how it works is we have this main cylinder which is for horizontal positioning, and the way it works is when you, as Viren already told you, that there are 3 push buttons for 3 different rings. You select like the desired push button for the desired ring, and the cylinder, this horizontal cylinder will move to the lid switch above that particular ring, and it will stop there. Then the lid cylinder will go down, and the gripper will close, and it will hold the bottle. Then yeah, and also at the same time, this lift cylinder will come up to in the spot for the gripper to grip the bottle. Then this lift cylinder will go down, and at the same time, this cylinder B, that's our cylinder, second cylinder B, that will go up. And after that, the cylinder A will move to the pouring position, and it will put the bottle in this dispenser, which will be rotated by the motor to pour the ring on one side, and then will be thrown out to the other side to the bin. So now we'll run it. We have air. Oh no.
Oh, no.
Turn around.
You think a bunny's gonna pop out of it?
Just don't. I wouldn't sit there in case it's
This one's not as fast.
I adjusted over there.
Yeah, it's very,
It's at 100. I adjusted at the.
yeah, it's quite slow.
We need 65.
That's already 100.
You need 65 PSI.
65.
You got your own local wet cleaner, right?
Yeah, it's down there.
Yeah, we have everything.
It's hiding behind you.
Oh, don't worry, don't worry. Everything you want to see. You don't want to see.
The one that went out, that was for a half volt and the...
This one,
No,
can you?
we'll talk about it. We'll talk about it.
You talking about?
Yeah. You guys are taking my stuff. What's wrong with you?
No, you can't run it without the pressure.
I'm always good.
Should have worked in this.
Yeah, well, no, we tried it.
Adjusted. So everything's working out. You come in here, you're okay.
Marco.
Okay, because it's sensing on the top.
We couldn't fit through the door when we couldn't.
No, it's not.
You gotta lift it up.
We lifted it up at the door.
So you guys have the rights to be sponsored by Chubby, right? I hope.
I know.
You can have it at home.
We went to NICES and discussed, rights and publication.
Where to go? So, which ring you want? I need 1, 2,
blue one.
You would like drink number 1?
Blue ones. Blue.
Blue.
So
Number 2.
You can go ahead and pass it.
Okay, make sure.
Now it will grip the bottle, lift it up. This cylinder will go down. So now it's clear, the passage is clear. Now it will go to the boiling point. And now the motor will rotate.
Very good. Very acetous. Oh, lovely.
Oh, fits too.
Yeah, very good.
It's not done, guys.
Good job.
I need from the bubbles.
Very good in 2 stages.
That's super.
And
Can she have ice with that?
We didn't put that in. We can afford to put that into the machine.
that's $200
Then we
more.
got another 100 more.
That's next year.
Design and development number 2.
Now, who is drinking this now?
Don? Don,
Since you want to
Oh, thank you.
okay,
So
one
what's
thing.
this little spring up there?
This is.
We're gonna tell you later.
That's for
That's secret.
aesthetics.
It's secret, Don.
That's what hard stop.
No, guys.
It's a hard stop so that we won't pass for our 4 point.
Guys.
So we'll explain why it got in there.
I saw it one day when I walked
Nana, you want to
So the another function we have in this, I mean not function, but provision is in case something is wrong with the sequence and you kill it like in between when it's not complete, then you can send all the cylinders back to home so you can start it again.
Again, yeah.
So I will assign it again. Suppose I drink 1
Make it drink 3.
and suppose pretend something is wrong, so I will kill the e-stroke. So now I turn it back on. I go back to the homing mode
Okay.
and I will press this button for 3 seconds so it will, everything will go back.
Good.
So and at this position we are make sure that this bottle should hold the this gripper should hold the bottle wherever it is, so it shouldn't drop the bottle in
Yeah.
between. So we close the gripper and everything is back now. So now we are ready to go again once you turn back to the main mode, the homing mode. And now Omari will explain the problems and solutions.
As described before, I know a lot of us were quite curious as to why we did the design this way. And I mean, like in any design, what happens is, I mean, the concept stages, you don't necessarily see any trouble that might arise. So once we finished, I would say 75% into our fabrication, we were ready to actually see the design concept here. And then we were beginning partially the testing stages. We stumbled upon a few issues and trouble. The first would be, the first trouble I would describe at this moment would be actually the PLC that we used. We're typically used to be working with the CJ series inside the D109 lab, but this is a CQ series. It's a little bit of an older model, and what the problem we encountered is that once we did our programming, we tried forcing all the outputs. The inputs were being registered, but we were noticing that it was not, we weren't causing any movement in any of our solenoids. So thanks to the help of the professors and our investigative procedures, we discovered that the problem we were having was that we were doing our addressing wrong. I believe in the CJ series, the addressing would go that we could first assign each of the input and output cards in the program itself to specified slots, whilst in this series, it's all based on addressing. So let's say our inputs are main memory would be considered from 0 to 99, while all our outputs would be 100 and above. So once we sorted that issue out, as you could understand, we're quite eager. So the first thing I would say I did was I forced an output, and I forced the A+ output. And what happened was this cylinder extended all the way. And at the time, we never had any of the reed switches to tell the cylinder to stop. So what happened was the cylinder would extend and it hit the dispenser stand. And I can't believe that thing actually it was still standing up. But we ended up breaking the gripper, and we ended up breaking a few things that were designed that required a lot of time to manufacture again. So I mean, now that we discovered that issue, we decided that okay, we can either move the stand or we can use this. The reason why we didn't decide to move the stand was there's a lot of things underneath, so we couldn't put the dispenser unit under here, the waste bin, sorry. So what we decided to go with was a butt stop. So as the cylinder comes, in case it misses the home cylinder, the home reed switch for whatever reason, it would get stuck into this compartment and prevent it from being proceed any further to damage the dispense stand. Another trouble that that we were talking about earlier was the reason why we used the DC motor rather than the stepper motor that we had envisioned. The problem was the power supply that we used caused a power surge, and it blew the card out. We fried a few things, and we fried a lot of the transistors here. So what we decided to do with that now, we went with the DC motor. But going with the DC motor, you come with another trouble, which is speed control. Now, as you saw with the pouring unit, the pouring sequence, it had to be quite slow, because if it was too fast, the drink would just jut out. Yeah. So thanks to another one of our professors, Mr. Gerardo, I'd like to thank him, he's not here today. He gave us the motor control unit, which allows us to adjust the speed of how fast the motor would turn. Super. So now we go a nice, proportional speed that we would require to go dispense and to pour out. Going back to the trouble that we established here was as this came and it hit the the stand, we noticed there's a lot of force that was here, and it almost took this out, took our carriage, and it caused a slight damage to the cylinder itself. So what the guys decided to do was, as this was being forced back, we needed to put a hole inside the A- side, so that too much for exhaust, so we wouldn't get that drift that you would see. So
we're getting drift backwards because it's more pressurized on one side, so we put extra holes here so it would exhaust quicker, so we'd have a steady rest here.
I mean, those are, I would say, were main troubles that we experienced while building this. Oh yes, the main trouble, I almost forgot. Sorry, I thought we designed it like this. Our initial concept, I thought we designed it. Our initial concept was the stand, with the gripper unit, the stand itself was designed to be exact 2 inches higher than what it is now. It never went up and down. But once you're doing the testing phase, we do the design of our gripper armature. As it would move across, you would then be limited to a predetermined order of how you did pick up the drinks, which would be, you would have to start from the third one first and then pick up and then pour in and then go to the second one and do it that way. So we came with the solution that, well, okay, now we needed to add more stuff to the design project and more to the programming, was we reduced this by approximately 2 inches. We put on a cylinder that I'm sure you guys saw, block cylinder underneath, so that as the gripper as the armature gets to the stop point, and this raises the drink so that a gripper could get it. And then once the gripper has a hold of the beverage, it would then lower to take the beverage out of the way so the gripper could move across without actually knocking over any of the drinks. So I mean, all our approaches to resolving these, I would say, was creative, and it really wasn't time consuming, but nonetheless, it was definitely a task, I would say. Jonathan?
Okay, I'm here to explain you about the process we went through to design this project. First thing was the deadline. So we had to plan out how we're going to build this machine all the way up to today, where we present it as a working machine. As you saw from the AutoCAD drawing, the design overall hasn't changed very much. You still have a cylinder on the top, you had a place to place your drinks, you had something to pour the drink, you had a gripper. The basic design didn't change at all. As we were working through, when we were designing our project, we found that in the machine shop, we would often find ourselves lining up, waiting for either the other group to finish working with their parts. And we split our group into two. One was to machine, finishing all the parts for this gripper and
the motor.
And yeah, the motor. And the other group was the electrics and the PLC programming, where we would do the programming early, at least get the basic logic of the program, so that when we decide to test out certain aspects of this design, we would have at least a basic ground knowledge of this whole design, so that even if the program doesn't work at all, we at least knew how to proceed and make the whole sequence work. The other part of the electric team was to build this card, well, we did build it early. It worked initially. That is why we didn't feel it was going to be a problem. But as Omari explained, it didn't turn out to be.
That's the faulty power source actually.
It was nice smoke. It was nice smoke.
On the display is not working, but the next thing we figured out, me and Marco, is the capacity of it was like 30 volts. It was running on 42 volts, while we wanted only 12 volts to our power. So we saw like 12 mushroom clouds coming out of these 12 transistors one by one. It was
Popping up.
Yeah, it was quite a show.
Yeah. So then with this out of the way, we got to a point where this machine was still not working. It was still not moving. As Omari told you, the cylinder, he forced the cylinder and it damaged the dispense stand. That was a setback to our original plan. So what we decided was to plan overtime, so that because of that issue, we decided to take more time than was required and try to get everything to work before the deadline. The idea is if we finish it early, then we would have very little worries. We could perhaps even add extra things to the project, modifications, calibration of the pouring.
This was all done by timers.
Yeah, it was all done by timers. That took a lot of time to correct it because it's not 100% accurate. If you adjust the timer 1 second more or 1 second less,
1/10 of a second,
even 1/10, yeah, it will not work. It will pour out, it will spill all over the desk. And also the last thing was with the damaged cylinder, it was sliding back, as Mark told you. We had to push that hole in, and after that we tested the program, the sequence worked, and then we felt relieved. For the first time in the entire
Hey,
project.
when was that?
That was like 2 weeks.
2 weeks ago?
2 weeks
Yeah,
ago. 2 weeks
Okay.
ago.
2 weeks ago, when the sequence started to work. And next is the development. Now, now underneath this.
Take all of the pins.
Take all of the pens. Yeah, good to see it all.
Just a little bit spinning.
So we are
Take it.
now. As you can see, there's a lot of electric work that has to be done, and one of the things we had to do was hook up a PLC to an actual application. And before that, we've never actually done that. The PLCs that we get in our labs have already been set up with their IOs correctly. And as you can see, you have those solenoids, or the solenoids are down on the right side. Next you have the regulator, then you have the DC motor control. You have all these relays, which control each of these functions. The master control relay, and we have our power source. And this is our power to the outlet. Now, while we were designing this, we've never actually put it all together. Last semester it was a pneumatic car, which would require the pneumatics and less of these electrics. When we added the PLC, we encountered some issues, as Omari has explained, with the addressing, what was the name? Addressing.
The programming itself.
Yeah.
Yes. When putting in the subroutines.
Yeah, the subroutines did not work.
We had difficulty with the subroutine. Our memory bits were staying latched within the subroutine, so our dispenser would continuously rotate. It wouldn't stop. So we had to take everything out and put it into the main routine for the program to work properly.
Now,
How many IOs you guys use?
we used most.
14?
Yeah, we have total 15 inputs and 14 outputs.
14 output.
That's about full. Yeah, we used most of it with all these reed switches. The
Luckily
motor
we use timers
control.
for a lot of stuff, or we'd even have
Yeah,
In our program, PLC
If you
program,
don't use timers,
you need reed switches all over the place.
So that, I mean, taking that into consideration, given more time, we could have actually decided to just run with these limit switches, more additional reed switches. Also, if you guys notice, I don't like pointing out flaws of our project, but if if let's say one of the drinks weren't there, maybe we could have had another diffuse sensor underneath the block itself.
Yeah.
So that if the drink wasn't there, it wouldn't proceed to that step, and it would allow the alert the user by maybe flashing to say maybe drink is just like any pop dispenser tells you sold out. So it's similar to
for
that.
that, but we need some more proximity sensors, and actually couldn't find anything from the lab. So, and again, a new input card and all.
Yeah, we would have needed those papers.
Okay, now our impressions of the project and what we felt we could possibly improve on. Our impression of the whole design was good, especially 2 weeks ago when it actually became something instead of just sitting here and not moving. we were actually very pleased, and considering the drink has been poured fully, very pleased today. Now, what we felt could have used improvements was, we did have a lot of arguments over little things, small things, particularly with the wiring, where one would do a certain portion of the wiring, the other one would do another portion of the wiring, and then when you bring them together, it doesn't quite match. As for the electrics themselves, we felt that if we had one person who was dedicated to doing all of this, that it would be much easier for that one person to go through the entire electrics without any arguments, no fighting over why you put this wire in this socket. And as for our conclusions, we enjoyed doing this project despite some of the disappointments that went along the way.
Very challenging.
It was very challenging, but overall it was fun. We've learned a lot of things, including putting all these three pneumatic, electric, and PLC all together into one package. It was a very different experience than what we were actually expecting. And we're very pleased with our project overall. Okay, thank you.
Well done.
Thank you.
I just want to say thank you to George Bruska and even Don for giving us all the materials that we needed and helping us with the machinery as well as the electrical.
Let me get loud too. D111.
Yeah, D111. Thanks for D111.
Now we didn't tell you it's a control panel, we swear. We just this thing. Good job.
Well done.
Good job, kid.
Good project.
Good job.
Yeah.
Oh, you guys have some drink too.
Yo, man, you see, what are you dreaming, man?
Everyone's agreed.
Very good.
Well done, guys. Both projects.
Thank you.
Proud of
Thanks.
yourselves.
Take care. Ooh.
Send that some point.
Yeah, yeah. Oh. Oh, that's why you didn't pick drink one, man.
Why?
What? It did.
Oh, we could pick up all of them.
It's just that
Just the same
one
sequence,
split
right?
Because we
Just-
have a spring.
Wow. That pour for the first drink was darn
Was good.
spot on, man.
I know.
Only one drink was
The
good.
lady, that's why.
That's why,
Cool. Not bad. I'm impressed. Good stuff, guys.
Thanks, sir.
Oh, clean them all up.
Would it be easier to just pick it up and put it in there?
Yeah, man. Don't say that, man. You're not gonna get any job now. Don't say that.
I know.
You're gonna get fired, man.
Wouldn't it all be easy to ride a horse to work?
Yeah, I need to talk.
I want to run a horse with some water here.
Did we hit the stop button? No, I we did.
Yeah, we did it in the picture.
In the sequence.
Okay, last one.
You want to press it?
Yeah, I wanna press it. One more.
What's going to happen if you press the start and pick up the bottle?
While it's running,
Yeah.
nothing.
It's not going to drop it?
Stop now.
Because they are double solenoid.
Yeah.
Oh, I was single. Yeah. I'm still gonna have a problem.
But